Hey, what's up? So in today's math tutorial, I'm going to show off how to find the horizontal asymptote of a limit while x approaches infinity. And what you need to remember about finding the horizontal asymptote is that the horizontal asymptote actually is the limit. So for example, let's find the limit of 3 over x minus 7 while x approaches infinity. This is a pretty basic function, so all we have to do is substitute infinity as x. So that's 3 over infinity minus 7. And you might be familiar with the fact that any number divided by infinity equals 0. So 3 over infinity actually equals 0, so that's 0 minus 7, or we can just get rid of that altogether. So we're just left with negative 7. So the limit of this function is negative 7. And of course, that's also the horizontal asymptote. So I'm just going to abbreviate it to HA equals y equals negative 7. You need to remember to always write it as an equation. Asymptotes are always written in equations. So here we are, I've graphed out the function using Desmos, which is my favorite graphing calculator. And we can see that the horizontal asymptote is indeed at y equals negative 7. I've just drawn it with this blue line, but we can also get rid of it. And we still very obviously see it's at negative 7. If you aren't familiar with what an asymptote is, basically this line will it will approach y equals negative 7, but it will never touch it. It'll go on for infinity. Alright, so I have another example right here. We have f of x equals 5x plus 2 over 6x to the fourth plus 3. And so the way we're going to want to go about this is first, we're basically going to completely ignore the plus 2 and the plus 3. We can just honestly pretend they're not there. They just become really unimportant once we get into higher degrees, such as to the fourth right here. So this will barely affect our function. From there, you can see we have 5x over 6x to the fourth. And from there, we're actually going to divide by the degree of the highest degree of the denominator, if that makes sense. So let me draw the fraction line right there. And then on the numerator, it's going to be 5x, of course, divided by x to the fourth. And we, of course, took that from the denominator. And then on the denominator, we're going to write 6x to the fourth divided by x to the fourth. Now, if we simplify that, we will see we get 5 over x to the third over 6. And now we're going to want to find the limit of that function right there as x approaches infinity. So again, we just plug in infinity as x. So then that's 5 over infinity to the third divided by 6. Since infinity is infinite, you can't really make it go to the third power. So we're just going to write an infinity under 5 over 6. And now, just like the previous problem, we have a number over infinity, which equals 0. And that makes this entire equation equals 0 over 6, or just 0. So we found the limit. And of course, the horizontal asymptote is the limit. So that is y equals 0. So I've just graphed it right here, and then I can also put in the asymptote right there, and we can see that the asymptote is indeed at y equals 0. Can get rid of that, and you will be able to see a bit easier. It gets so close to 0, but it never reaches it. Okay, I guess Desmos rounds it up, but if you zoom in a ton, like a ton, you can see right there, it's not touching 0 yet. It's just round, or it's just a very tiny number, but it'll never reach 0. But yeah, I think that's about it. See ya.